Hey, everyone. All right, thank you for having me. Yeah, I am pretty excited to talk about this. So, sort of the scope of this talk is, I've done a lot of sort of applied work in transparency over the last few years, helping bring it to ecosystems like PyPI and Homebrew. And this talk is supposed to be more of like a scattered-brained, here are all the things that we think about when we're trying to secure these ecosystems. And here are some places that I want people in this audience to think about where transparency could be useful or applied in the future to reducing the amount of latent trust we put into packaging managers, packaging indices, that sort of thing. So sort of going to be like a stream of consciousness, hopefully. If we haven't met already, my name is William Woodruff. I'm an engineering director at Trail of Bits. I run the open source team, which is the team that's responsible for contributing to PyPI, Homebrew. We do a lot of work on Python and Rust cryptography. And then more generally, Trail of Bits, we're a cybersecurity consultancy, roughly half remote, half in New York City. We do a whole lot of different things, and I'm happy to talk about all of them, but I'll do that offline. Yeah, so as a sort of high-level agenda, I want to talk a little bit about open source and trust, do a quick background on Python packaging for people in the room who aren't super familiar with it, talk a little bit about like what it means for the Python community to trust PyPI, why we should even want a zero-trust PyPI, and then how do users currently trust it, et cetera. And then both what we are currently doing and what we plan to do and what we could do to further reduce trust in PyPI 1 year from now, but also 5 and even 10 years. So first, I want to talk about open source and trust. I think everybody in this room already knows sort of this. I'll kind of breeze through it. Open source is everywhere. Everything we do these days, to a sort of first approximation, has some amount of open source in it, and we all trust. By the way, I talk really fast, so if I talk too fast for you, please just raise your hand, and I'll try to slow down. But by default, I'm a kind of fast talker. Yeah, pretty much everything we do to a first approximation has some amount of open source in it. And an unknown, uncountable, and indeterminate number of people are maintaining that open source for us. People who are qualified to do it, and also people who aren't qualified to do it, people who we don't know their qualifications, et cetera. And as a matter of, like, as a facto state of affairs, we trust them whether we want to or not. One of the things that we do in open source is we realize that the trust is actually a paradox when it comes to the things that we consume. In order to trust open source more, we actually need to be able to trust it less. So we want to be able to qualify and constrain the ways in which we trust it to assert the trust that we currently latently assume. There's various numbers of ways we manifest this, but the one that comes to mind a lot for me is in sort of traditional package signing or code signing setups, you have a keyring of trusted signers. And a really classic bug is transitive trust across that keyring, where you're really supposed to trust each member of that keyring to sign for one specific thing, but instead you trust the entire keyring to sign for everyone. And so someone who you trust to sign, widgets now signs for Chrome, and that's not really what you intended. So with that in mind, let's talk a little bit about PyPI. So PyPI is the Python package index. It's pronounced PyPI. It's the default source of Python package distributions, which are the things that you pip install when you are programming in Python or in pretty much anything that integrates with Python. One thing that I think is a little bit surprising to people is that it's not a dumb index/host. It's not a thing that you just dump files onto. It does a bit of processing behind the scenes. Not a lot, but a little bit. It has user and organization management, so you can create an account on it, you can create an organization on it, and you can manage those things. And then the namespace, while not closed, is in fact administered. So there are operators on PyPI who every day receive reports of spam or malware and actually take those things down. So we do in fact curate the namespace, although the namespace is not curated for quality, which comes into play later because some people actually assume that it is curated for quality. So with that, I want to talk about a little about trust within PyPI. PyPI, being the sort of de facto index, occupies a unique position of trust within the community. People assume these things. They're not things that are they're taken for granted. We have a basic integrity sense of trust, where people assume that when you download a file, if you download that same file tomorrow, the digest of that file does not change. Whether or not the contents of the file are good is sort of a separate question, but basically the basic package integrity does not change. There's also a basic assumption of authentication integrity. Users and orgs can only upload to projects that they already control or are given control over by someone who previously controlled them. There's this more fuzzy availability trust assumption, where people assume that any time of day, anywhere on Earth, pip install works. And this isn't, in fact, always true, but increasingly we're seeing people assume that it is. And you see a lot of sort of embarrassing corporate failures happen because people try to pip install and don't have backoffs or failure modes set in place. And then finally, the scariest one, which I can't impress enough how shocking it is that people believe this, but they really do, is that presence on PyPI implies quality and trustworthiness. And I want to bring this in because this is not something that we can solve abstractly, but we can, I think there are interesting things we can do in the transparency world that make it harder for people to abuse this assumption, even if they still make it. So with that, I have a sort of like way that I order these things in terms of easiness and then extremely hard at PyPI scale. And talk a bit basically about how the way I think about these things is that an attacker who can compromise one or more of these properties is both a security and a sustainability risk to the ecosystem as a whole. So obviously from a basic security perspective, they can break into machines, they can steal things, they can do anything that a malicious agent would do. But also there's a sustainability aspect to this in which the modern software stack is built around the assumption that PyPI is available and that everything that you use to build your applications remains available. And if an attacker can undermine that trust, that latent trust in the availability of the ecosystem, they can do sort of a large degree of damage to the stability that we all assume in the software that we use every day. So I think a lot about that as well in terms of trust. So with that, I want to talk about how PyPI is doing right now. So on the package integrity side, things look pretty good. I frame this as like, can a malicious or compromised PyPI serve you malicious files? The good news is that for a while now, PyPI, wasn't always the case, but PyPI now serves files over HTTPS, so transport integrity fine. We promise that files don't change after upload. And files are served with their digest ahead of time, and then you can check that digest. This itself doesn't really mitigate an attack, but you can use it to sort of pre-plan, especially if you already have the digests. So in theory, clients like pip can audit PyPI for package changes via hash binning. So they'll download the dependencies and then at a future point, recheck those dependencies for changes. However, Python, because it's a pretty old and legacy-driven ecosystem, doesn't have a standard packaging log file format. And so the number of clients that actually do this is pretty small. So this is an area for obvious sort of non-transparency, but security nonetheless improvement. But then something that I also want to flag, which I think is kind of surprising and I think does have transparency implications, is that while files themselves are immutable in PyPI, releases are not. And releases are made out of a sequence of files. And so one thing that an attacker can do, which I personally think is pretty surprising, is they can upload a more precise specifier for a release. So instead of an sdist, they can release a wheel for a specific subarchitecture. And then anybody who's on that subarchitecture will instead resolve that newer wheel file for that same old version, which means that even if you're checking hashes, it'll appear to be like the tofu hash, where it's the first one. You'll just assume it's good. And I think this is pretty surprising from an index malleability perspective, where you sort of assume that a release is created and then is frozen a certain point after its creation or after its upload. And this is somewhere that index transparency in the form of like a Go checksum database could be of service. On the authentication authorization side, again, I sort of frame these things like how easy is it for an attacker to take over a project, and assuming they do, how easy is it for the community to detect that the takeover is malicious and not a authentic transfer of ownership. Again, at a basic sort of non-transparency level in terms of trust, PyPI has had strong multi-factor since 2019, and since 2024, this year, that multi-factor has been mandatory. We've also removed the ability to upload with passwords. You have to use API tokens or trusted publishing now. That also factors in, I'll talk a little bit about PEP 740 and what we're doing on the Sigstore side of things. That factors into that. And we also have a mature policy mechanism which requires public disclosure of intent to take over a project before admins act on it in the form of this thing called PEP 541. However, this all happens on a public GitHub issue tracker, which nobody, as far as I know, there's no real sort of machine-readable schema to it. You just sort of say, I want this package. And then an admin, some degree of months later, says, no one is currently using it. Go nuts. So not exactly easy to audit, not exactly transparent, other than in a very basic data is public sense. And as sort of probably everybody in this room knows, that kind of innocuous transfership of ownership is exactly how the XZ attack happened. Someone said, I want to help. You don't want to help. You don't want to do it anymore. I'll take over maintenance. And that's how we ended up in that situation. Going sort of further down to the not as green set of things. So in terms of availability, I think in terms of, can an attacker disrupt the overall availability and smooth operation of Python? This goes into like the more abstract trust of, can they irreparably damage the confidence the community has in the index? And this has several facets to it. One is, if an attacker can cause downtime or availability issues to the index, users may temporarily or permanently switch to less trustworthy mirrors that aren't over HTTPS, or that don't provide hashes, or that are in countries that are susceptible to meddling, et cetera. And then even the perception itself of a less reliable PyPI, one where outages, even if they don't cause huge issues, occur more often, can induce worse security practices, like I said, and also in the form of like updating less often. So we want users to regularly update so they get patches to their projects, but the perception of a less reliable PyPI induces poor security practices there. Sort of on similar notes, how do I want to frame this? We have this weird like double edge with PyPI where PyPI, most people don't experience any issues when they pip install. I mean, I think our success rate is well over 7 nines. But as a result of this, nobody caches when they hit PyPI, so everybody just hammers it full on, and they go straight to Fastly CDN, which, to Fastly's credit, performs extremely admirably under the large load of PyPI, and they do it for free. However, as a result, the entire ecosystem has this like latent assumption in it, which is that you can infinitely hit and hammer PyPI, and your request will always be served, and you don't have to maintain a local cache or any sort of local caching mechanisms. And similarly, we have like a supply-side protection in terms of availability, where PyPI can hit the emergency brake and say no more uploads or no more downloads if we're in the middle of an incident. However, this again induces a long-term shift towards distrust in the index, which runs the risk of less secure default user behavior. So again, something that we just sort of abstractly think about. Okay, and then finally, sort of the really crappy thing, package quality. So again, I want to really emphasize PyPI itself being trustworthy in terms of its integrity or availability does not imply that packages on PyPI are trustworthy, but in reality, most users don't know or believe this, even though we say it pretty much everywhere. This is driven in part by Python's culture, which I think is a huge boon, but the belief that Python is a big tent where large independent communities simply don't know really how pip works. They see it as like a magic thing that they type in and they get the features they want. And it's sort of like a curse of success where everything works so well that it can't possibly be malicious because it's just magical. And of course, it's also driven by a little bit of like wishful thinking, where, and this is true in practice. 99% of the time, if you mash random packages from PyPI, you're not going to get malware. And so I wouldn't recommend anybody do it, but in practice, users see this and they believe that they can get away with it. Even if things break, they won't be broken in a malicious way. They won't be served intentionally malicious code. This takes multiple forms. People believe that PyPI is curated beyond basic like admin operations, which is not true. It's entirely uncurated, besides malware removal. They also believe that PyPI will remove vulnerable or dangerous things, even if they're not malicious, which is absolutely not true. We don't remove anything unless the user explicitly removes it. And same thing for explicitly malicious malware. We do try to remove it, but there's no actual removal timeline guarantee. If you notify the admins, typically it's within 24 hours. Typically it's within, I believe, even 8 or 6 hours. But we don't actually commit to that anywhere because it's a mostly volunteer-run project. Okay, so that's the current state of affairs. I want to talk a little bit about things that might be more of interest to this room, which is what could we do for a zero trust future on PyPI. So I'll use the same sort of schema again to inform that. So on the package integrity side of things, sort of the most basic, we have this promise of file immutability. And of course, what we really want is to make that enforceable via auditability from the community. So right now that's sort of de facto enforceable if individual users go to the effort of checking the integrity of the individual files they pull via hash. But we can do this in a structured protocol level way through something like Go's checksumdb, which concretely that model, given the other constraints in the Python ecosystem, is a eminently workable model. It's one that fits pretty nicely into the existing scheme of pull down distributions. You already know their hash, or you can pull their hash and once we have a lock file, it becomes much easier. However, it's pretty common for people to have requirements files, which are essentially lock files, but not quite. And that's a potential acceptable stopgap for that kind of scheme. Separately related to this is the issue I mentioned around release mutability. We don't want an existing release to resolve beyond a fixed set after a certain window of upload. So pick an hour, 4 hours, 20 minutes after that window. And this again, combined with some level of like baseline artifact transparency, binary transparency, reduce the incidence of surprising resolutions, as well as ways for an attacker who gains access to a project to influence pre-existing versions in a surprising way. They're forced into the open by pushing a new version, which causes more events. It changes the metadata on PyPI, for example. This has some challenges to it, but these are mostly technical, mostly around users having the existing expectation that they can upload new versions or new files to an existing release when new versions of Python come out, for example. So we want to change the impression here among the Python community that releases are in fact cheap. You can do them as often as you want. You don't have to keep the same release alive for years on end. More on the authentication, authorization, integrity side. This is another area where we think that some degree of integrity enforced via transparency is something that we're thinking about and we think would be potentially very valuable. However, this goes from left to right in terms of like where we're pretty certain to where we're less certain. And so one thing we think about here is, well, if we can make the list of ownership changes to packages publicly auditable, then people who depend on those projects can say, well, I trust requests as long as it's maintained by the current maintainers, but if something gets maintained by someone whose name I don't recognize and they joined PyPI 5 minutes ago, I probably don't want to resolve that for now. I probably want to put that on like an alert list and go triage it. This is desirable from a triage and incident response perspective, but it's also pretty thorny because, again, we're not a legal entity. PyPI is a legal entity, but it isn't a company. It doesn't have the real capacity to do things like handle PII. We try to keep the amount of of non pseudonymous identifiers on PyPI to a pretty bare minimum, and anything that involves a permanent immutable record of who owns what, which potentially includes human names, is sort of risky to us. But at the same time, it's something that we're looking at. And this is where PEP 740 comes in. So as sort of Hayden hinted at yesterday, one thing that we are doing right now is over hopefully the next 2 or 3 weeks, about 18,000 packages on PyPI will begin testing overnight via their current automated CI/CD upload process. So what we're going to do is we're going to bootstrap on top of GitHub Actions, GitLab, et cetera, which use OpenID Connect. We'll use that to perform a Sigstore flow, which will then attest that the build was in fact produced on a specific machine identity. And this we're comfortable with because it's a machine identity, not a human identity. And so we're okay with having an audit log, a public, this is all going to be checked into Rekor. So we're okay with this all being public and immutable because it isn't a human identity per se and causes fewer issues. However, we would also potentially want to do it in the future for email identities, et cetera. Availability, this is even more ambiguous. So like I said, the real risk here is sort of inducing users into insecure by default behavior where PyPI becomes unreliable and they do insecure things instead. We don't really know how to do this. One thing we could do is have more explicit official CDNs. We could have relationships with CDNs other than Fastly and have fall-through mirrors where if there's an outage for whatever reason or just load is too high, you can fall through to a separate set of trusted entities who will run these, who will pay for them. PyPI itself probably won't. In theory, this could be made more trustworthy by tying in with something like artifact transparency because you can now reduce any need to trust the mirrors themselves because you can just check that the inclusion proof for anything you pull from the mirror is consistent with, or has an inclusion proof and is consistent with what you would get from PyPI. But these set up time requirements too, so we're sort of just shuffling the cards here. Like we don't really know how to solve this on a more general level. And then finally, package quality. So again, the goal is to require less trust in PyPI. So it's a little bit, it's self-referential and self-defeating to have PyPI itself be the arbiter of package quality. Not only is it impossible from a curatorial perspective because there simply isn't enough time in the day, but it doesn't make any sense in terms of reducing overall trust in the index. However, again, something that we're thinking about at a high level, there's really no plans for this yet, but something that we're thinking about at a high level is the use of community reviews that are then committed to some sort of transparent log as a path forwards here. So there's been, I think, some initiatives in the Rust ecosystem around things like, I think it's Cargo, CREV, and similar tools where you can basically emit a machine-readable summary of how you reviewed a package and sign that, in which case we would do it with a machine identity or similar. And in theory, you could then store those, and then you have an auditable trail of reviews, which would remove the need for PyPI to audit these things or to review them or curate them, but at the same time be able to serve them in a way that the user doesn't have to trust PyPI to serve them honestly. However, again, this is an entire can of worms. This essentially implies a web of trust. It implies trusted reviewers. We don't want anybody to be able to spam reviews, that sort of thing. And so these are hard, unsolved problems that we could use the insights of people in this room around. So then, even further into the future. So in terms of things that are currently tractable, things that we are going to do in the near future, like I said, PEP 740, we're going to do more package attestations. I pulled these numbers yesterday. As of the last 18 months, about 400,000 files have been published PyPI using trusted publishers. That means that when we enable package attestations over the next 18 months, we expect at least that many, if not more, attestations. And the really cool thing I like about this number is that that's only a tiny fraction of the overall number of files on PyPI, but by proportion of downloads, it's a massive proportion because the projects that have adopted trusted publishing are the most active and most widely used ones. So things like requests, cryptography, URL lib, baseline foundational pillars of the ecosystem will overnight opt into attestations. And again, I'm happy to talk about this offline because it's a pretty big scope of things, but one thing I really want to impress on this is that it's it's machine identity bound code signing without any configuration required. A user who can already publish to PyPI overnight, once they upgrade their publish action on GitHub Actions or CI or GitLab or similar, will immediately overnight begin signing with it, which was a key goal of ours, was to make it impossible for users to forget to sign or test their packages. A little bit further out is binary artifact transparency. Again, we view Go as an empirical success in this matter, and there are only marginal differences between PyPI and Go in terms of the baseline expectation that the clients have around pulling artifacts from it. So there are some standard considerations, but they're marginal in my opinion. And again, we really like this because it's zero touch and requires no real precise user configuration besides a standard log file format, which still needs to come into existence in Python. Further into the what might be tractable side of things. Like I said, this open-ended release problem is a pretty big one. It's technically trivial to fix. We can just forbid changes to releases after 10 minutes or something like that. But doing so will break a huge number of existing expectations around how you can publish new files to releases on PyPI. Trustworthy mirroring. Again, we're thinking about this in terms of a natural follow-on to something like attestation or binary transparency of the Go sort. But this is going to, again, require a lot of coordination and thought on who we choose to mirror with, who we want to encourage, and also if we get more major downstream users like GitHub Actions to cache, we want them to also cache things like inclusion proofs. Something that I've brought up a little bit less, but another thing that's potentially tractable is like namespacing on PyPI, and then being able to transparently monitor changes to a namespace, such as Google changes package, some core Google package. There are both hard and soft ways to do this, hard being like a fundamental change to the package structure, soft being we reuse some existing part of the package prefix as a namespace identifier, and these have various technical trade-offs. There's sort of widespread consensus in the community that this is extremely desirable, but almost nobody agrees on how to do it. So it's a little bit further out in terms of tractability. But this doesn't really directly impact index trust. It's more about simplifying the package and identity tracking story, which will be important for things like attestations, where you want to say this identity should always be pinned to this package, or when it changes, I want to know. Things that aren't yet tractable. We are not going to, at any near point in the future, we are not going to remove the user's obligation to make informed installation decisions. You still need to not pip install malware. Current architectures look too much like PGP Web of Trust, and we need sort of insight into ways to avoid those kind of bottlenecks and pain points. Another thing that isn't currently tractable, but I think will be tractable, a little bit more tractable than the previous, is turnkey log monitoring and witnessing within the Python ecosystem. So both for attestations that we talked about in the PEP 740 context, but also index-wide transparency, we want people to both monitor and witness those entries. The tools are already out there. All the moving pieces are present, but the level of effort required is currently at the level of a determined and technical user. Whereas what we want is for anybody who publishes to PyPI can then click a follow-on link to an external service that says, monitor this package identifier for me and tell me when it gets changed. That's sort of the dream. Which leaves me with my call to action. So, like I said, this was not really focused on the technical details of what we've done so far. I'm happy to talk about those. My team has mostly worked on that. It's mostly on the sort of like how we think about trust on the index side. I want this to be the opportunity where that intersection sort of collapses, where I get to talk to people in this room about how you see transparency systems reducing the amount of trust that people need to place in the index, which then allows us to divert more energy towards things that cause trust issues on the index. And finally, as a sort of an observation generally, all this stuff is easy compared to actually getting into users' hands. One thing that we've observed over the years, my team helped build API tokens and two-factor for PyPI. Building those things was far, far easier than actually getting users to use them. And this we expect to be as, if not more true for transparency schemes as well. And so we could use insight into ways to, again, make this a turnkey, zero change default option for users in the ecosystem. And we could use your help with creative solutions to that. With that, thank you very much. That's my contact detail, and I think that link should work. If it doesn't, let me know.